From DataStax, this is the Distributed Data Show podcast.
On this week's episode of the Distributed Data Show, I'm talking with Russ Spitzer. That's Russell with two L's, not one, just in case you had any question about that. This is Jeff Carpenter, Developer Relations at DataStax. Welcome to the show, Russ.
Hi, it's great to be here.
We've had you on before talking about Spark, but it's been a while. So what I thought we could do is do a little bit of a recap on, what is Spark plus Cassandra, why do people do that? And then just to set a little bit of context real quick, bring everybody up to speed. And then we're going to dive into some exciting new stuff that you've been working on. Does that sound like a plan?
Yeah, that sounds great.
Nice. Okay. So yeah, tell me a little bit about Spark, maybe a little of your background from it, and then why we get into this world of Cassandra plus Spark.
Yeah, sure. So, my history is actually started when in biological computing. I got my degrees in computer science and math, and then got a grad degree in bioinformatics. And that's when I knew I really wanted to do distributed computing and batch analytics. And that's why I joined DataStax. And after many years of being there, I now spend a lot of my time working with the integration between Spark and Cassandra. So the DataStax Spark-Cassandra connector is now pretty much the only and most popular way of connecting Cassandra and Spark. And it basically provides an avenue for taking your data that's inside of Cassandra and using it inside of a Spark environment. I actually recently did a talk on this. I'm forgetting what the name of it is, but for Scale by the Bay, I believe it's called Why Spark. I actually think I also did this at the DataStax Accelerate last year.
I gotcha. You do a lot of talks. Let's be fair.
Yeah. I boiled this down into why would you want to use Spark and Cassandra in the first place? And I kind of have three main categories that I like to think about. First is ETL, which is that I have data somewhere else and I need to have it in Cassandra, or I have it in Cassandra and I need it somewhere else. And one of the great things about Spark is that because it has all of these different connectors to all of these different systems, once you have a connector for both systems that you want to use, moving data between them is almost trivial. I mean, you basically set up your reader and writer for each side, and Spark does all the checking for error correction, makes sure that everything succeeds successfully, makes sure that everything is in the correct formats and in the correct casted data types and all that kind of stuff for you. So it's really a great tool for moving a huge amount of data from one place to another and making sure it's done correctly, regardless of where you're taking it from and sending it to.
Okay, gotcha. That's actually kind of maybe an underrated aspect of using Spark as a tool for ETL. I don't hear that quite as often, so that's really good to highlight that.
Yeah, I mean it's huge because that's usually the entry point for a lot of folks. They start doing that and then they realize, wait, there's things I want to do to the data in flight. And that gets to my second big category, which is doing kind of batch analytics, which is I'm taking all of this data out, but I don't really need it all copied directly from one source to another. Maybe I just need it in another format or generated into reports where I have summaries of how the data is represented, things like that. So this is where you can use Spark as basically an analytics framework on top of your Cassandra data, because normally you can't ask questions of Cassandra of all of my customers last year, how many bought more than 100 pounds of cheese or something? Because Cassandra isn't set up to answer broad questions like that.
Right.
You have to very much structure your queries. It's very much about questions like, how much did customer A buy last week between the hours of 5 and 10?
Yeah, it's going to do its best on that. Targeted queries that are going to support directly actions in your application, right?
Yeah. But Spark kind of expands that. It basically opens it up to everything else. So any other question you might need to ask, you can start asking with Spark. One of the cool things that Spark has is this Spark Thrift server, which is kind of grown out of the Hive Thrift server. And in DSC, we package it as something called the always-on SQL server. We give it an HA component. And basically, that lets you connect a JDBC client to your Cassandra data with no fuss. So basically, now you can run ANSI SQL against Cassandra, and it will distribute all the things that need to be distributed. So if you ask for something that requires like a giant join and shuffle and all of the stuff, Spark will just do that all for you. So it's a great way of providing access to everything in your data,
right?
And not just little bits of it at a time.
Yeah, this is the secret cheat code for doing SQL on top of your Cassandra data.
Yeah. And then the last big category that I like to tell people about for Spark is using it for streaming use cases, because it's got a great streaming engine, and because of its connectability, because of how many different connectors it has for different sources, it provides a great platform for integrating data between things. So for example, if I've got a stream of data coming out of Kafka, and this data needs to read a subset of my Cassandra data over and over and over, because like I have a catalog and I got 40,000 customer requests and I need just those 40,000 partitions, Spark is a way to automate all of that fetching, requesting, managing concurrency, all the things to make it performant and efficient. And as a user, you don't actually have to know how all of those things work. So it's a great platform for connecting different data sources and streaming environments as well.
Nice. Okay, so I'm going to add another question to my list, and I'm going to pop it on to the end here, because I really want to get to the stuff about the Spark Cassandra connector. But let's circle back later on and talk about this combination of Spark, Cassandra, and Kafka. How those three interplay together, because I think that's something that people can get a little bit confused about. So we'll set that to the side for just a second, and we'll come back to it. The main reason I wanted to have you on the show is, of course, to talk about the new release of the Spark Cassandra connector, 2.5 release, right? So what are the highlights?
Yeah, so this is a new frontier for DataStax. So as you know, for a while, DataStax was doing a lot of work, only inside of our enterprise product. And we actually had a bunch of really awesome features that we had only packaged with DataStax Enterprise. And Spark Cassandra Connector 2.5 is us taking all of that, taking everything that we had internally and putting it all out in the open again. So now all of the things that you could have only gotten if you were using DataStax Enterprise are now available in the open source connector. In addition, we've also added the full upgrade to the new Java driver 4.0, and connections and the ability to work with Astra. So you can actually now connect with the same connector, open source Cassandra, DSE, Astra, all at the same time, same code base, same configuration.
Nice. Okay, so previously, 2 releases of the connector, an open source based release and a DSE based release. Is that right? Or was it?
Yeah. It was a little more confusing, but basically, if you got DataStax Enterprise, there was a version of the Spark Cassandra connector that was included with it.
Yeah.
And that version differed from the open source version.
Okay, so it was a physically separate version or distinct version.
It was physically distinct, yeah.
What does the upgrade path look like for somebody that wants to, either coming from previous version of open source connector or the older DSE connector to this new one?
Yeah. So the most difficult part of the upgrade path, because we've basically made so everything that works previously still works.
Okay.
But there are some changes if you were manually using the Java driver. So as you know, when we upgrade the Java driver, Guava is removed. The entire future operations are all changed around. Async code is changed. Because of that, if you were manually using the Java driver and you were using Java driver 3.0 code, that no longer will work. You have to change to Java driver 4.0 code. But that's really the only case where you have to upgrade. If you were just using normal Spark APIs, everything works exactly the same. So it should be a source code compatible upgrade. So you just take your code, compile it against the new artifacts. That should be it.
Yeah. Okay. So and I happen to know, I monitor the internal Slack channels. So I happen to know that there was an effort to of kind of some of the things that you went through in the process of updating the Spark Cassandra connector from our DataStax Java 3 driver to the DataStax Java 4 driver. I want to make sure I get all my version numbers right. I think I did it.
The DSE version is 1 to 2, but now 2 is gone, and there's only open source 4. Doesn't really matter. But yeah, it's a bit of a rough upgrade if you have a lot of code around configuration.
Okay, gotcha.
But,
and you apparently did.
Well, I mean, that's the thing, is the Spark Cassandra connector had its own set of configuration parameters and things like that.
Okay.
So because of that, all the parameters that you use to configure the Spark-Cassandra connector are the exact same ones. But the underlying code that sets up the connection, the underlying code that handles futures, all of that stuff had to change, but it's all internal to the connector. So you as a user don't really have to know anything about it. The cool thing, though, is that we also added in the additional hooks so that you can do that same file-based configuration. So if instead of the Spark-Cassandra connector, you've got your application configuration file, you can just use that as your configuration for the Spark-Cassandra connector.
Awesome. Yeah. Okay. So good. And I would guess that you would say like totally worth doing. Lots of in terms of the updates within the open source Java 4 driver. Basically paying down a couple of years worth of technical debt, like API redesign. You went through the work of the upgrade and kind of know what was involved, but not to put words in your mouth, but I think hopefully the end result is a little cleaner, works a little bit better.
Yeah, I mean, it's one of those things where it's painful to get to that point for a lot of code. For some applications, I think it's actually be very easy to do that upgrade. But if you have a lot of custom connection and configuration code, you basically have to rewrite it if you want it to behave the same way that it used to behave.
Right.
But once you're done, everything is much simpler to maintain. I mean, one of the huge things in this upgrade is that there's no Guava dependency. And because of that, it's way easier for us to build binaries that are compatible with Spark. I mean, this is the kind of stuff that was a big pain previously.
Nice. Did I understand that you use the asynchronous APIs under the hood of the Java driver?
Yeah. So we use asynchronous APIs in several places. Basically, so Spark has a couple levels of concurrency. One is that it spawns up individual tasks that run separately, and those are independent chunks of work. And it basically gives one thread to each of those. And then within that, you're actually allowed to, of course, do more concurrency or parallelism if you want. And it doesn't make sense with Cassandra to have a single thread like execute a query and then wait, execute a query and then wait. You want to be proactively fetching data basically as quickly as you can. So we have a couple parameters that allow you to tune how many simultaneous requests are happening at a time, and we use our own semaphores and things like that to limit how many asynchronous requests are happening at a time. But it's using the asynchronous APIs under the hood.
Okay. Now, are there any significant API changes in the 2.5 version of the connector?
So yeah, again, for an end user, there really aren't any.
Okay.
Like all of the cool DSE stuff is mostly around Catalyst, which is Spark's internal optimization engine. And basically what we have is a bunch of special rules, special analysis patterns that look at how the data is about to be executed, how the query is about to be executed, and rewrite it if it makes more sense in Cassandra to do it differently. So one of the big examples is something we call the direct join. And the direct join is something that makes a lot of sense if you know a lot about Cassandra, which is, say I've got a whole large set of partition keys, maybe like 100,000 partition keys. And then you say, I have got a Cassandra table that has 1 billion records. Well, what's the fastest way to get those 100,000 partition keys? Well, it's not to read all of the Cassandra data, and read all of the keys, and then compare them. Because we know in Cassandra, the easiest way to look up a key is to just look it up. It's one of the fastest patterns in Cassandra. So one of the problems with the way Spark is constructed is that it doesn't have that notion of like this join where you just ask for all of these pieces individually very quickly. So what we did is we wrote a series of Catalyst rules that basically looks at the join that it's about to do, analyzes the components of the join and says, this is the kind of join that Cassandra can do without any kind of scanning or shuffling or big data manipulation, and rewrites the plan and produces a plan that instead takes all those keys and asynchronously requests them. So basically you turn an operation that could have been a full table scan into 100,000 asynchronous key lookups, which is going to be incredibly faster. We got a bunch of parameters around tuning when this optimization takes place. You can all see those details in the documentation.
Cool.
But yeah, that's one of the things we did.
I know I have friends that want to dig into those details and ask. I don't know if I know to ask the right questions about the data structures and algorithms that are in use. Now we're into the area of writing query optimizers. Maybe that's where I jumped off the path of computer science. I'm not sure.
We have to do it. I mean, this is one of the other big features that we included in this is the ability to get TTL and write time out of Spark SQL, which is actually more confusing than you would think in Spark SQL because they aren't real columns, right? I can't ask for the write time of just any column because it doesn't exist. There's only write time in TTL for specific columns. And if I make them present all the time, if I say select star, and I always pop up the write time in TTL alongside each column, that's like a really bad user experience.
So you're talking about pulling in the underlying from the underlying Cassandra data, the write time in TTL, some of which is row level, I guess, for partition key, for any column that's part of the key, it's probably at that level, at the row level, and then individual columns beyond that.
Yeah,
I made it sound harder than it was probably.
It's kind of like that. I mean, especially if you get into the differences between how collections are treated between various point releases of Cassandra. They're like between 3.8 and 3.9, collections go from having a single value to an array of values and things like that. But basically, in order to support that sort of thing, we actually had to do a very similar thing where we wrote custom plan information where we said, if you're asking for TTL, if we see this function that looks like it's asking for TTL, find the underlying Cassandra column, make sure it's valid. If it's valid to get the TTL from that, rewrite the plan so that function doesn't exist, and instead we'll pretend there's a column there right now and you can pull it out. So we have to do some hoop hopping to kind of allow things that are very easy in CQL. But now, if you're using the Spark Cassandra Connector 2.5, these things are possible. You can select TTL and write time just like you were doing it in CQL, in SQL, in Spark SQL.
Very cool, very cool. And this is why I love talking to you, because not only do I learn things about Spark, I also learn things about Cassandra.
So many things.
So many good things. Okay, well, tell me what's going on with Spark 3.0. This is on the horizon, right? I thought I saw a beta release pop up on the radar recently. What's happening?
So RC2 was just voted down, but RC3 is coming very soon.
Oh, okay.
We're getting very close to the finish line on the new Spark release. And the main thing that's holding it up is work around data source v2, which is also the most exciting thing about Spark 3.0.
Go ahead, let's do it.
So we're expecting to get it very soon. So we're actually working on the patch right now for the Spark Cassandra connector to do this. And what Spark 3.0 brings is this data source v2 idea, which is basically that the way the original implementation of doing data sources in Spark worked is it was very opaque to Spark. It was very hard for the data source to tell Spark details about how the data was arranged, how it was cataloged, metadata about it. Data source v2 is trying to implement a more flexible approach, so you're able to expose more information to Spark so Spark can make better decisions in its own query planning. Hopefully we get to the point where I don't have to do a lot of behind the scenes work to make direct join work. And then eventually we can have join optimizations just be something that data sources can expose to Spark without a special path. But what this really means for an end user is that the connection between a data source and Spark is going to be much tighter than it's ever been before. So previously, if you wanted to access a table in Cassandra from Spark, you have to write a little bit of metadata that explains this is what the table is called. These are the connection parameters to connect to the Cassandra cluster, and so on and so forth.
Right. Key space name and table name, right?
Yeah. Key space, table name, connection host,
yeah,
user credentials, all this stuff you have to specify all the time. Connecting to multiple clusters is kind of hard because, for each of these tables, you're continually setting all these parameters and all sorts of stuff. And even worse is that Spark doesn't intrinsically know about all of the tables that are in your Cassandra. Like if you say, I'm going to connect to the cluster here, it doesn't know to look up all of the metadata and represent them inside of Spark SQL. You have to register all of the tables individually yourself. Inside of DSE, Inside of DSE, we actually had a few hooks to automatically populate tables with these fake entries that were like, these are the wrappers that you would have made that refer to all these tables. So for a lot of DSE users, they got the experience that the tables were automatically known to Spark, but it was really kind of a wrapper around a behavior.
So you were behind the scenes going in and doing like describe key space and describe tables, and the equivalent of that for the metadata.
We were behind the scenes. We were doing all of that and mapping all of the things.
Okay.
So like we were writing all these statements that otherwise you would have had to do. In Spark 3.0 with the new data source API, we can do a direct representation of the catalog inside of Spark. So what this means is you don't list what the table is called in the table, a key space name. Instead, what you do is you specify, this is where my Cassandra cluster is, and this is how you connect to it. And once you've done that, every table in key space is automatically registered. So now there's no extra work. You just say, this is where this cluster is, and this is how I describe it. So you might say like, Cassandra cluster 1 is specified by this connection host, these usernames, and blah, blah, blah. And then when you write Spark SQL, you just write select from Cassandra cluster 1 dot keyspace dot table, and that's now valid.
That's so much
You don't have
nice.
to do anything.
So you've totally decoupled the how do I connect to it from get me the data.
Mm-hmm. So not only is the catalog there, it's also fully modifiable in both directions by Spark. So that means that if you change the key space or the tables inside of CQL or any other process, they're reflected immediately inside of Spark. And in Spark, you can do the same thing. You can change the DDL of your Cassandra cluster now from Spark SQL.
Oh, nice.
Which means if you want to make a new table, you can make a new table in using SQL in Spark. So you can do all this stuff that used to be impossible. So for example, say I've got some data in a MongoDB cluster and I really want to make a Cassandra table about it, a Cassandra table with that data. Before, I would have to go into CQL. I'd have to make my key space. I'd have to make my table. I set this all up. I make sure all the schema is correct. And then I would go to Spark and I would read from Mongo and write into that table. So I have to use two different tools. And I have to make sure things match up all along the way, right? Because I have to make sure
line
Mongo
your schema
data
up and right.
Now, what you can do is you can write create table as select. And that will automatically make the table in Cassandra using the schema that you get from Mongo. And all you have to do is specify what the partition key and clustering columns are going to be. And that's it. And it will do all the work of making all the metadata, making all of the schema information, and moving everything in one command. So it's going to be a whole new world for doing these kind of operations. Everything will be much easier, and you won't need multiple tools anymore. So that's very exciting for me.
It's pretty awesome. So let me, will you zoom out just a little bit on the larger context of what is in Spark.3, because I know that there's sort of a running joke on past Spark releases that there's like, oh, it's a new release, there's a new API, oh, we don't use RDDs anymore. Now it's all about data frames. Like, is there any of those kind of big ticket surprises in Spark 3?
I mean, that's one of the main reasons that Spark's having a hard time getting out this next release is there's some discussions about how the SQL dialect has to change to fit some of these new ideas, right? Because previously the create table syntax was basically Hive's create table syntax, which was a little limited because it could only express certain things. And we want to have a much more generic language for creating tables now because we want to support any provider who wants to make a catalog implementation. So you want to be able to write a create statement that makes a MongoDB table and also makes a Cassandra table and also can make a Parquet file and also can, you imagine the engine, right. It should also be able to work with that. So that's the only thing folks may have to look out for because this upgrade to Data Source v2 does change some of those ideas. A few things that used to be possible are no longer possible, but they're things that didn't really make a lot of sense. So something that I'm sure a lot of folks are not familiar with is that Spark 2 and 1 had a set of modes for writing data frames. You had a mode called error if exists, you had a mode called append, you had a mode called overwrite, and you had a mode called ignore. Now, what do you think that overwrite might do?
If the data exists, you're going to overwrite what was there before.
It will truncate the entire source that you are writing to and rewrite it entirely.
Well, that's not necessarily what I would have expected.
Mm-hmm. So what does append
Overwrite
do?
all.
Yes. So what might append do if that's what overwrite does?
Well, I guess I'm going to hope that append doesn't do a truncate, but it's just going to add on to what's already there.
It will add, but it could also overwrite. An append was basically the way of adding additional data, but for certain sources, append is a insert which can remove the previous data. So
yeah, there's a little semantic mismatch there, isn't there?
So basically, all of those modes only make sense if you're thinking about files, right?
Okay.
So if I'm thinking about files, overwriting a file, obviously I have to delete the old file.
Right.
Appending, I can't just add data in the middle of the file, so I'm always just adding more files.
Yep.
So
yep, makes sense.
So those were a little confusing, and one of the things that Data Source v2 does is basically say, in Data Source v2, we're just not going to have these weird behaviors. Like, you are going to have a behavior where you add data, and you're going to have, an overwrite operation, but the overwrite operation, specifically, you have to say what you're overwriting. Things like that. So things make a lot more sense. There should be a lot less gotchas. One thing we actually did is in the Spark-Cassandra connector, we said that if you use the overwrite mode, we send up a warning first that's like, we won't let you do this unless you also set an additional option that says that that this is going to do a truncate. Because too many people, are like, oh, well, I want to do upserts, right? I want to upsert into the table,
right.
But the semantic of the operation is drop table, right.
Yeah, okay. So it occurs to me that a number of our listening, viewing audience is going to want to try some of this stuff out. So both the Spark 3.0 release, but also the Spark Cassandra connector 2-5. How do I get a nice demo with maybe a pre-built data set? Is such a thing available?
Oh man, I wish I had something. I'm pretty sure Alex Ott, who's our coworker here at DataStax, has got actually something prepared up as a coordinated release with Zeppelin. So you actually have everything set up with Zeppelin. But we'll have to ping him and hopefully add a link at some point.
Okay, we'll dig that up. Maybe we'll see we get Alex on and talk about the demo. We're investing a lot more lately in examples. We're actually building out the whole examples section of the website to populate that with stuff that is well curated and even better maintained. So because there's plenty of old example code out there that applies to past releases. So anyway, Rebecca with us here in Devereaux is working on a bunch on that. So we'll be talking a bunch more about that coming up. Sorry for I get to do ads for my own stuff on my own episode.
That's your prerogative, I think.
So. Nice. So is there anything else interesting in terms of that Spark Zeppelin integration that's worth diving into? Is that like the go-to combo tool set?
It's really common. I mean, so if you look at what Databricks as a company has built their entire model on, is we're going to provide this notebook experience directly tied to a cluster, and that's their big selling point. And I think that makes a lot of sense because these notebooks are a really great way to not only write code, but also to share what you've done. They're a really good platform for marking up this is what this code does. This is the result from this part. I'm producing this and this and this. So I think it's really good for prototyping.
All of my code is totally self-documenting, by the way. I'm not sure what you're talking about.
Oh, man. Yeah, I mean, definitely not for me. I just got a review on one of my PRs for this Data Source v2 work, and Yarek was telling me because I was using a fold right at some point, and he's like, why are you folding right instead of folding left? And I was just like, I don't even know.
It was late,
I'm right-handed. I think at the moment I was just like, you know what? We should go from that end instead of this end.
Good catch.
And
very cool. I have one more thing I want to ask you, which is because it comes up from time to time. Sorry if it's a non sequitur out of left field, but I was here. Kind of, there seems to be a debate or a question that especially new people to the area have about. Okay, I want to most effectively combine Spark and Cassandra from a deployment perspective. And one model is, okay, I have my existing Cassandra cluster. I'm just going to spin up a separate Spark cluster and point it at the Cassandra cluster, by means of the connector, and operate that way. And then something that I've heard us articulate, espouse from the DSE perspective is, okay, I'm going to actually set up my Cassandra cluster with a separate data center. So it's the same. It's one conceptual cluster, but replicating the data to a separate data center, and then I can pound the crap out of that by co-locating Spark on that Cassandra cluster, and go to town and have operational analytics and don't affect the performance on my source cluster. So, what are the pros and cons of these different things, or how do I know what's the right deployment model?
Yeah, I mean, this is a hard question, and it's really about what is easiest for your organization. Because the different models have severely different pros and cons. So obviously the DSC approach is based around the idea of the simplest possible deployment. You have the same software installed on every machine. When you start it up, it's just very easy to have Spark there at the same time. The trade-offs are you aren't able to scale the analytics portion as easily as you might like. And you can't have a transient analytics because you have to basically have this data center that's up all the time.
Oh, yes.
But you also do get that, that second replication of your data, so it's easier to not affect your OLTP work. We also have locality built into the Spark Cassandra connector, so it will take advantage of co-located Spark and Cassandra nodes. But something I'm seeing a lot more now, especially with the rise of more cloud-based Spark providers, is that people want a more transient Spark environment, or they're working with, within their organization. Their organization has a large Spark cluster somewhere, and they want to use resources from that. So in that case, I think it's, it makes sense to just keep it, not co-located, because you have someone else who's taking care of the Spark portion for you. You really only want to be responsible for the Cassandra part. Still probably makes sense to separate out a DC that you're going to read from. And of course, if you really are trying to avoid constantly hitting your Cassandra database, do daily pulls of all of your data and move it into Parquet files on S3 or something like that, so that you have a static piece of the data that you can work on without impacting Cassandra load at all. So those are basically your two ideas. Is are you as a team managing Spark and Cassandra? If so, co-deployment probably makes most sense for you because it's the least things you have to take care of. While if you're part of an organization that already has a lot of institutional Spark knowledge, is already providing Spark as a service, then it makes sense to use that instead and not do co-location. And I think for a lot of groups starting up now, it makes a lot of sense to keep your Spark in some kind of cloud environment and keep your Cassandra, somewhere else. So you don't even have that option. So if you're using Astra, then you want to use for Spark, you want to use EMR or Azure's, I forget Azure's brand name for their Spark as a service, or Databricks Cloud. Actually, maybe it is Databricks Cloud. I think they've branded Databricks Cloud as Azure's Spark as a service. But yeah, that's basically what I'm saying is don't lose any sleep because you can't co-locate. I think these days the majority of the benefit is in operational simplicity for people managing everything. The gains you get from the co-location are great, but I think compared to the operational gains, it's not as valuable.
Right. No, good. This is a really great explanation of the trade-offs that you're making here. And I would guess that because of the improvements in the Spark Cassandra connector, the performance of non-co-located Spark and Cassandra is as good as it probably can be, given the recent advances.
Yeah. I mean, we're stuck right now really with Cassandra as our bottleneck most of the time. There are very few instances we've seen where the network is really the bottleneck for this sort of thing. Of course, your mileage may vary depending on where you're egressing and moving data to and from. It may make sense to limit that if at all possible. I mean, we all know that if you've got a cluster that's not on
Right.
AWS and you're moving data to AWS. I mean, it's not the rental cost that's going to cost you; it's that data
It's that
ingress, egress.
transmission.
that's
Yep.
gonna hit you.
That's where they get you.
So, there's trade-offs all over the place, and you really have to figure out what are your optimization goals. I still think doing DSC as a little package is probably the fastest way to get everything set up and in an environment where you can work on it all easily. But for a production environment where I'm at a company where we've got 1,000-node Spark cluster, it doesn't make sense to co-locate.
Right.
So.
Right. Of course. Yeah. There's always, I mean, the larger the enterprise, the more of these decisions have already been made on your behalf. And you just have an environment, a self-service environment, which is great to kind of play into. So yes, trade-offs everywhere. Well, thank you very much, Russell with two L's, one L, no, two L's. Very much appreciate you coming back on the show and hanging out with us. And we will see you next week on another Distributed Data Show.
All right. Thanks so much for having me.
Thanks for listening to the Distributed Data Show. Please subscribe with your favorite podcast app, give us a rating, and